All right, let's talk about accuracy and precision. All right, in the measurement. So when we measure something, accuracy and precision are something that we always talk about it. How accurate your measurement is, how precise your measurement is. Okay. All right, let's start with the definition. So accurate, just like playing dart. You throw the dart. Is that accurate? Yes, it is. I'll try to answer me right here. Just answer on the screen. Okay. Is that accurate? No, that's you are way off, right? Is that accurate? You suck at it, right? This is really bad. So, how do you know it's accurate though? Well, we compare all the position of these darts to the middle, right? In the measurement, the accuracy reflects how close the measure value is to the true value. Okay, so we have to compare all these measure value to the true values. That's the accuracy. Precision is different. Precision is, here we go. Let's take a look right here. Compare measure value to one another. I'll give you some example. Compared to one another, all these three attempts are really close, so they are precise. Okay, so these are precise. Is this precise? Yeah, we compare each dart, the position of each dart to one another. Right, and they are all close, so these are precise. This is not precise. Okay, you really suck at it. That's two. You're not accurate and you're not precise either. Okay, so accuracy, you compare the measure value to the true value. There will be one true value. You compare all of your measure value to that value. Precision, you compare all your measurement together. How far off? Or are they really close together? That's precision. Okay. All right. Let's give you some example here. So, if we are to measure the mass of this guy, okay, of this object, and the true value is 2.11 gram, we're gonna measure value the mass of this object with these scales. We have scale A, B, and C. Okay. Now put this object onto scale A 4 times. We have this number 4 times, 4 attempts. All right. Use scale B, we got this set of number, and scale C, we got this set of numbers. Okay. All right. The first question: which one is the most accurate? How do you know if your measure value is accurate? You compare to the true value. All right. When I say compare, this is how I do it. I'll take 2.118 minus 2.111. You get this is how much this number is off from the true value. Okay, 2.110 minus 2.111, you get negative number 0.001 gram. You can do all this. You can see how much each number is off from the true value. Take a look at scale B. All right, this is a bit more detail. I do this way so you can see it's numerically. All right, so you can see the exact number here, not like just like that's really close. I mean, that's not really like a quantitative way to do that. So I just show you the real number here. All right, take 2.113 minus 2.11 gram. All right, 2.114 minus 2.111. All these do the same thing minus that 2.111, the true value. So you should get this right here. Okay, a little bit better than the scale A. All right, so these numbers are closer to the true value compared to scale A. And do the same thing with scale C. Oh, this is much better, even more accurate. Okay, so you can do this way to show which instrument or which equipment is more accurate than the other. These are in comparison. All right, so that's the first question. So who is the most accurate? So the scale C. Okay. Now, who is the most precise? How do we measure the precision? Well, the precision, we look at all the measure value if they are close together, right? Here's how I do it. I'll just take the highest number minus the lowest number. That's the gap. That's how. That's like the area of the gap of the measurement. Okay. Do the same thing with scale B. Take 2.114 is the highest, the lowest 2.109. You get the gap of 0.005 gram. That's how they off from one another. Okay. No, I'm not talking about the true value right now. That's just for accuracy. Right now, precision. Just look at right here. Each measurement. Okay. All right, in C, the highest number 2.112, the lowest number 2.111. So that's how much they are from one another, right? So the most precise, of course, the scale C. Okay. In statistics, if you take stat, you might have heard the term uncertainty range. Basically, if we just take the gap right here divided by 2, we do plus minus sign. Okay. When you report the number, this is how we do it. We average out all the measurements. Let's say you get, I'm going to make up the number. So 2.113, I'm guessing the number should be in the middle right there. All right. Let's say you average all these number and you get 2.113. You report the number with the uncertainty range by saying the average is 2.113 plus minus 0.0045 grams. That's how they do it instead. Okay, but we don't do it in here, so we not go to that level. Okay, right now all you have to do is to determine who's the most accurate, who's the most precise. That's all you have to do. All right, pause the video right here. Have you do it on your own, and then once it's ready, check with me. Okay, who's the most accurate? Again, start with the accuracy. We compare all these values to the true values. All right, so we have 4 students measure the temperature of something. All right, who's the most accurate? So the true value is 122 degrees Celsius. Like from A, start with A. Take all these minus the true value. You should get this. Looks like student A is a little bit off to the left side, which means to like the negative side. All right. Student B, same thing. Still kind of tilt to the left again, so negative number. Right, but better than student A. Student C, right, we have kind of symmetrical. Okay, negative, positive. All right, 4 and 2, and D, the most accurate right there, slightly far off from the true value. Okay, that's the most accurate. All right, who's the most precise? It might be multiple answer. Okay, so I'm gonna take the highest number 118 minus the lowest number 112. That's about 6 degrees Celsius apart. Okay, the uncertainty range is plus minus 3 degrees Celsius. In B, I do the same thing. So take the highest minus the lowest, so 2 degrees apart. So the uncertainty range is plus minus 1, even better. All right, and so in C, highest 126 minus 118, same thing, 6 degrees. Uncertainty plus minus 3. And in D, the highest 122 minus 121. The gap is 1, so the uncertainty range is 0.5, right? Plus minus 0.5. So D is the most precise, and B and D are really close. I mean, in terms of in the real situation, plus minus 1, plus minus 0.5, they are close enough. Okay. All right, so that's pretty much about the accuracy and precision. All right, we have class activity number 1, and so I kind of give you part of the hints, part of the answer. All right, this one I give you answer here, but you have to show me how you do the math. I want to see you do the math. Okay. All right, let's one more video about this topic. So.